3.5, graph, square root, and cube root functions. We have graphed square root functions previously when we did transformations, and we're going to be doing them now with the cube root. We have our formula, f of x equals a times the root of bx minus h plus k. We know that h is the horizontal shift on x. Remember about that negative sign, it's always the opposite of what you see. We know that k is the vertical shift on y. We don't see too much with b, that's going to be more in pre-calculus. B is what's being done to x. It could be a shrink or a stretch. And then the a value, there's a lot that goes on with the a value. The a value is being multiplied to the function. If it was being multiplied to x, it would be on the inside with x. So a is about being multiplied to y, the function. And if it's a whole number, it's a vertical stretch. If it's a fraction, it is a vertical compression. And if it's negative, it's a reflection. We also know that if x on the inside was negative, it would be a reflection as well. And again, we won't be seeing too much with the b value. That'll be more next year. Example 1, graph 1/2 the square root of x. State the domain in the range. Compare the graph with y equals the square root of x, the parent function. So we always start with the parent function, and we're going to choose values that work out evenly in that square root. So we're going to choose, we're not going to choose any negative numbers because negative numbers would be imaginary numbers. So I'm not going to choose any negatives when it's an even root. We're going to start with, let's do 0 and 4 and 9. The square root of 0 is 0. The square root of 4 is 2. And the square root of 9 is 3. And I'm going to graph those. 0, 0, when x is 4, y is 2. And we don't have 9 on the graph, so I'm not going to use that one. And I sketch that graph. This would be y equals the square root of x. Notice that this is actually half of a parabola. The other half that would be down here would be the negative square root on the outside, negative. That would be your quadratic. We know that they are inverses of each other, and so that is your quadratic, your parabola. The next thing that we're going to do is look at the transformation. What is going on here? We have a half that's being multiplied to x or to y. If it was being multiplied to the x, it would be with the x. So this half is being multiplied to the y value. It's being multiplied to the function. We know that we're going to have x, and then we're going to multiply our y values by a half. And we're using these y values here. A half times 0 is still 0. A half times 2 is 1. And we don't need to worry about this, but that would be 3 halves. So we still have 0, 0. And then we have 4, 1. And that's all we're going to use. So that we can see when we're multiplying by a half, it is a vertical shrink when it is a half. This is y equals a half square root of x. And the parent function. Final part from this function would be to talk about that domain and range. We know that the domain starts at 0 and goes to positive infinity. It includes 0 and goes to infinity. The range also starts at 0 and continues to positive infinity. Example 2. From the cube root parent function, we are going to look at these transformations. We can see the cube root, there's the parent function, and then it's being multiplied by 3 and it's being multiplied by a negative. We're going to start with the parent function. For a cube root, we can have negatives, it's an odd root, and we can have negatives under the radicand. Let's do -8, that's a perfect cube, -1, 0, 1, and 8. The cubed root of -8, it's a cube root. The cubed root of -8 is -2. The cubed root of -1 is -1. -1 times -1 times -1 is still a -1. The cubed root of 0 is 0. The cubed root of 1 is 1. And the cubed root of 8 is 2. -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. It's coming in. It curves up and curves out again. And again, the cube root is similar to x cubed. If I turn it sideways, we would see that this would be a negative x cubed, left tail up, right tail down. And it has those same features of that little curve going on there. All right, the next thing we're going to do is we're looking at the 3 that's out front. What is the 3 doing? Is it being multiplied to the x or the y? It's being multiplied to the function, so that means it's being multiplied to y. Identify any vertical stretches or compressions. It's being multiplied by 3. Is that a stretch or a compress? That is a stretch for the y. And so we are looking at D. It's being stretched by a factor of 3. Y is being stretched by a factor of 3. So that means we would have x, and we're going to multiply our y values by 3. That is a vertical stretch. And I'm looking at my y values, and I'm going to multiply them by 3. 3 times -2 is -6. 3 times -1 is -3. 3 times 0 is still 0. 1 times 3 is 3, and 2 times 3 is 6. And so we are vertically stretching these. -2 becomes -6. 1 becomes -3. 0, 0, 1, 3, and 8, 6. It's coming up through here. And we can see that vertically it's been stretched by a factor of 3. Next, we are looking at the negative. What is the negative doing to the function? Am I negating the x value or the y value? It's not the x. We're negating the function, therefore the y value. So we have a reflection. It is the x that is being negated. So that is a reflection over the x axis. That means on this next step, we're continuing from where we've already been working. So x is going to be the same, but we have a -3y now. We're multiplying a negative to all our x values. That becomes +6, +3, 0, -3, and -6. We're working from where we left off. We don't go back to the original. We keep building on the function. All right, so that means that this point at -6 becomes +6. -3 becomes +3. +3 becomes -3. +6 becomes the -6. Make sure that you're using the previous function. And so we can see that this is coming in, it comes down, and then it's going back out again. And there is our final function reflected over the x-axis. F of x equals -3 cubed root of x. We have f of x equals the cubed root of x. And we have f of x equals 3 cubed roots of x. B, identify any vertical or horizontal shifts. We have none. Nothing being added to the x or subtracted from the function. And that is it. The domain of the final function, the domain, is going to -infinity all the way to +infinity. The range is also going from negative infinity to positive infinity. Example 3, from the square root parent function, we are going to look for these transformations. We can see that it's being multiplied by 2, it's being multiplied by a negative. We have that x has something going on with 3, and then the y value with 2. We will start with the parent function, and using positive values, we'll use 0. The square root of 4 is a perfect square. The square root of 9 is a perfect square. The square root of 16 is a perfect square. The square root of 0 is 0. The square root of 4 is 2. The square root of 9 is 3. And the square root of 16 is 4. We have 0, 0. When x is 4, y is 2. When x is 9, y is 3. And that's as many as we're going to get on our graph. So we'll just use those 3. And there is the square root. Next, we're going to look at the negative. Is it being multiplied to x or to y? It's not being multiplied to x. It's going to be a reflection, and it's being multiplied to the y value. So the y value is being multiplied. That means that it's a reflection on the x-axis. It's going to reflect over the x-axis. 0, 0 is still there. We see that this is 2 units away, and perpendicularly it will still be 2 units away. And then this value is 3 units away, and it will be 3 units away in the reflection. You were multiplying a negative to all the y values. That would still be 0, and then -2, -3, -4. Now we're going to look at the 2 that's being multiplied. Is the 2 being multiplied to the function, or is it being multiplied to x? It's not being multiplied to x, therefore this is being multiplied to the function, which means it's being multiplied to y. Y is the function. We have, that means if it's the y, it's going to be a vertical for y. So we're multiplying 2 to our y value, and that will be a vertical. It's a whole number, it's not a fraction, so a vertical stretch. We're multiplying 2 to the previous function. 0 times 2, -2 times 2, -3 times 2, and -4 times 2. All right. So multiplying by 2, it's still 0. Multiplying -2, we get -4. And multiplying -3, we get -6. And now at this time, I am going to do the horizontal and vertical shift at the same time. It's being shifted to not -3 for x, but it's being shifted to 3. So I'll be adding 3 to my x's, and I will be adding 2 to my y values. Here's my hk, and I'll be adding 2 to the y values. Identify any horizontal shifts, that would be the x, and so we said that we were adding 3 to our x values. That is a horizontal shift, right? And then we have the vertical, yikes. And the vertical shift is y plus 2. All right. Vertical shift, we're adding 2. The horizontal shift, we are adding 3. Vertical shift up. So from the last place that we just landed at, we're going to do 2 moves. We're going to the right 3 and up 2. So I'm going to the right 3 and up 2. There is the center, the beginning of this square root. And then we are going right 3, 1, 2, 3, and up 2. Right 3 and up 2. All right, we added 3 to our x values, and then we added 2 to the previous y values. Adding 2, adding 2, adding 2. And these points should be on the graph. Again, we did it without doing any of the chart. Let's see, we have 3, positive 2, 7, negative 2, 12, negative 4, and the last one's not on the chart. You don't have to use the table of values at all. You can simply do the calculations from the original and using each point from the original. The domain of this function, where does this function start? The final function. The domain starts at 3 and goes to positive infinity. What about the range of this function? The range starts at 2 and goes to negative infinity. We're going to start with our original, which is always good to see. We have an odd function, and so we know that negatives are okay in the odd function. We have a cubed root, and negative numbers are fine with an odd degree. The cubed root of negative 8 works out evenly. The cubed root of 1 works out evenly. The cubed root of negative 8, cubed root of negative 8 equals negative 2. The cubed root of negative 1, the cubed root of 0, the cubed root of 1, and the cubed root of 8 is 2. Coming up through the middle with a little turn. All right, multiplying our y values by 3. And so negative 2 becomes negative 6. Negative 1 becomes negative 3. 0 stays the same. 1, 3. And negative 2 times 3, 2 times 3 is 6. And then I'm going to shift all of these points for this one. We are shifting left 4 units. So I'll be subtracting 4 from my x values, and we are shifting down for our y value. Be subtracting 1 from the y value. All right, so left 4, down 1. 1, 2, 3, 4, and down. 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 Domain for this function is all the reals. The negatives work, the positives work, everything works. It's all the reals. So we're going from negative infinity to positive infinity. The range is also all the reals. Negative infinity to positive infinity.